Hello everyone, welcome back. In this final example this week, we're going to do one more round practicing working with objects, except this time we're going to be using a sound file. So let's just dive right in. The first thing we are going to do is save this sketch. Let's call this object sound. Save it, and we're going to upload an asset that a sound file that we can work with. So we're going to go upload file, and then let's grab a file. Now I have this audio file here. It's a WAV file, but you can also upload MP3s, I believe. This is a short loop. It's the Amen breakbeat. If those of you are familiar with that, it's a very classic breakbeat, and we're going to use it for this example. Okay, so just a little sound clip. You could use any sound file for what we're about to do. So I've uploaded this WAV file now, and the first thing we're going to do before we can talk about the sound object is we are going to create a variable, and we're going to load our sound file inside preload. So just like with the previous examples, always a good idea to load your objects inside preload to make sure by the time you get to setup and draw, the objects are actually available. This is particularly true for the sound file because it is the biggest file we've used so far compared to the image. Okay. So what we're going to play with today is the p5 sound file. Now the sounds in p5 are actually part of a library. Okay, we're going to talk about libraries more at the end of the semester. It's actually part of the p5.sound library. It is a library that is included by default when we use the p5.js editor. If we take a look at the source here for the HTML, we see that we include p5.js. We also include this p5 sound library automatically. So other libraries we have to manually add, but the sound one is included. And it gives us access to a whole bunch of sound objects. We are really only going to scratch the surface in this short video and talk about the sound file object, which allows us to load and play sound files. We're going to create them using loadSound, much like in the same vein as load font and load image. And then once we have a sound file object, we'll see that there's a whole bunch of methods, right, or functions that are part of this object that we can then use to play the sound, manipulate the sound, and so forth. So this is the full list, and we're not going to look at all of them today, but if you want to explore that, you can read through the reference and see all the different things that you can do with a sound. All right, so let's start with loading our sound. So we're going to say load sound, and then we're going to put the name of the file we want to load. So in my case, it is amenbreak.wave. So if we simply load a sound, right, just like with load image, this just creates the object. We then have to use it in our code. Sound is a little particular when it comes to the browser because there are certain policies in browsers that kind of prevent websites from just randomly starting to play sounds. Just because that's annoying, and you don't want to open a web page that's going to just all of a sudden start to blast some sound. So usually it kind of requires the user to have interacted with the web page before sound can play. It's a little bit different in the context of the p5.js editor because this is kind of a subsection of the page. We're already interacting with the editor, but if we were to look at our sketch kind of using the full screen version that, when you share your sketch here, when you share your sketch, right, using the full screen direct link, it's important to note this consideration because you might play with sound and wonder why no sound is playing. So a good rule of thumb is to start playing sounds after there's been an interaction. So I like to do it inside mouse pressed. So this way, I know the user has clicked inside the window and therefore the browser is going to be okay with playing the sounds. Okay? So once we have a sound, we can play it using mouse pressed. We can say sound.play. So sound.play is going to play the sound through once. It's going to play it once and then stop. Okay. Sound.loop, let's try that. Save my sketch. So that's my sound file. Okay, that's the whole Amen breakbeat. Sound.loop is going to get the sound to play on a loop. So this is going to go through once, right? Then it starts over. It's just going to loop the sound. Obviously, this is going to get annoying if this is playing the whole time while we are talking and explaining this sketch. So I'm also going to implement mouse release here. And the idea is that the sound would only play while I am holding my mouse down. And what we're going to do when we release the mouse is we are going to pause the sketch, pause the sound object. So now you can't see me, but I'm pressing, and then pauses the sound, and then loop resumes from where it was left off. Okay, so this way we're not going to constantly hear this droning breakbeat in the background. Okay. All right, so we have a sound object now. What can we do with it? Let's just have some fun in this example. The first thing we're going to do is we are going to draw the waveform. Okay, and the way we do this in with the SoundFile object is we used a method called getPeaks. Find it here. GetPeaks. Okay, so GetPeaks goes through the sound file and then gives us an array of amplitude peaks. So I'm sure all of you have seen a sound file kind of visualized before, and what that allows us to do is draw the waveform. Okay, so it's going to scan through the buffer and give us all these amplitude peaks. Okay, and these amplitude peaks are numbers. It doesn't say so here in the documentation. Which is a bit of an oversight, but they are simply numbers, amplitude values that are between 0 and 1. Okay, so let's do that. We're going to create an array here because our sound file is not going to change. We're going to define a variable called peaks, and then in setup, once our sound has been loaded in preload, we're going to say peaks equals sound.getPeaks. Okay, and then so this is the amplitude peaks array. So amplitude just means volume of the sound. Okay? And then let's see how we can use this so these are going to be values between 0 to 1. Okay, so let's use this to draw these amplitude peaks. So in draw, okay, we're going to draw the waveform. We're going to create a for loop. So this for loop, rather than go through all the peaks, we're just going to make it fit the window size. Okay, and there are probably more samples in the buffer than we have pixels in the window, so it's not going to. It's going to definitely fit. Let's write a for loop that's going to scan through all from left to right, and we're basically just going to draw horizontal lines here to show the amplitude peaks. So first, let's figure out the index, right? That corresponds to where we are on the screen. So we're going to map we're going to map I, which goes from 0 to width. We're going to map it to an index into the peaks array. So that goes between 0 and peaks.length, okay, -1 being the last value. And then just like we did before in the previous example, we're going to use the floor command to make sure we round it down. Okay, so this is an index into the peaks array. Yeah. And that's going to give us access to a number between, let's call it peak index so we don't get confused. Okay, and then the actual peak value is going to be this. Okay, peak index. So this is a number between 0 and 1. Okay, so let's leverage this by drawing a line. Okay, so we'll say, let's say we're going to multiply it by 50. So this is just going to show us the bottom peaks, I would think. Oh, and we should set a stroke of white if we want to actually see something. Okay. So this looks like that. This is just kind of showing it inverted here. Maybe we'll translate so that we are down the middle here. Translate down, And now we can see these are like the peaks of our waveform. We can see some of them actually go negative. So this is actually between -1 and 1. And if we wanted to see like the full waveform, right? Let's, instead of going from 0 to peak, we're also going to go negative here. So we're going to have the line extend on both ends. It's going to look like this. Okay? So this is kind of how we're used to representing wave files. Okay? And then finally, this 50 here, maybe we want to tweak the height. We're going to make it into a variable. Let's call it peak height. This is going to be, maybe we'll make it 100. And then we'll replace this 50 with our variable. Let's separate this so it's a bit easier. Okay. So now I am going to be able to tweak how big I make this waveform. Cool. So that's already one thing we can do. This is in a similar vein as with the image example, right? We could access the pixel information inside the image. With the sound, we can get the amplitude peaks, and we could also, if we wanted to, get the value of individual samples inside the sound file. So one thing we can do with that is create a visualization of what the sound looks like. I can still play it. Right? We could also do something where if we wanted to visualize where we're at in the sound file, we could decide, figure out where the playhead is and then change the color of the lines we're drawing, right, based on that. So instead of making everything white, we could figure out, first, let's figure out where the playhead is, and then, excuse me, and then we're going to use that to figure out which lines should be white, and maybe we're going to draw the other ones a different color. Okay? So one of the ways we can do this in the sound object, go back here, is using the current time method. Okay. So current time, right? This is going to tell us, if we have a sound object, is going to tell us what's the position in seconds that we're at in the sound file that's being played. Okay? And duration is the overall duration of a file in seconds. So we can use these two numbers and some map action to figure out, kind of a mapping between X coordinate on our screen and where we're at in the sound file. So the playhead, right, is going to be mapping the current time of the sound, which goes from 0 to sound.duration. Okay? We're going to map this to a number between 0 and width. Okay? And here we're going to say, let me shift that over a little bit. Okay. And here we're going to say if the playhead is less than I, so I is where we're at from left to right, we're going to set a white stroke. Else, we're going to set a gray stroke. Let's say, see what that looks like. So this is the opposite. Why is that? Oh, guess let's just shift the sign here. Yeah, that works. Yeah, sound current time, 0 to sound duration, 0 to width. Interesting. All right. So moving on, that just gives us a little visual animation, right, where we're at in the sound. And we can do all sorts of other things. For example, one thing I like to do is play around with the rate. So not the sample rate, but the playback rate. We can set that here using the rate command. And this allows us to do some fun tricks like values. This changes the speed and the pitch of the sound. And then when you put negative numbers into the rate, it actually starts to play in reverse. Okay, so let's play around with this a little bit. we're going to make the rate, we're going to make the rate interactive. Okay? So let's go into here. So for example, like in draw, we could say sound.rate. Like if I put 2, it's going to play back double speed. If I put -1, it's going to play in reverse. Right? And if you put -2, it's going to play in reverse, but kind of slow, fast, right? Or if you put 0.5, it's going to it's playing forward, but at half speed. Okay? So you kind of get the idea of what you can do with rate. It's kind of a percentage. So let's explore this. We're going to calculate a new rate. We're going to map, let's say we're going to map the mouse Y coordinate. It goes from 0 to height. Let's map it to a rate between, let's say, -2 and 2. So we can explore that a little bit, and then we'll set the rate accordingly. So now if I click in the middle, I get a rate of 0, right? This is negative, and then it goes faster. And then moving down, I'm about my normal rate here. Cool. So you get the idea. The other thing we can do is, just to wrap up this example, we might want to jump around in the... Where's my mouse cursor influencing this? Oh yeah, of course, if I set a negative rate, now it's reversing the file. Yeah, okay, that makes sense. We're also gonna make it so that if I click from left to right, we're gonna jump to different sections in the song. Okay? So we could do this in mouse pressed here. We're gonna say first we're gonna stop the track so that it goes back to the beginning, okay? And then we're gonna calculate, start it with loop, and then we're gonna calculate a new position to jump to. So we're going to map mouse X, which goes from 0 to width. We're going to map it to a position between 0 to sound.duration. And then we're going to jump to that new position. So we can also jump around in the sound using this method. So now I'll be able to click somewhere, play from that section, and then my up and down cursor position changes the rate. It goes backwards or forward, or slowly or quickly. That can be pretty fun to play with. All right. Okay. So just to recap briefly, right? We can load sounds using the loadSound function. That gives us a p5 SoundFile variable, right? And that variable, again, to reiterate the point of this week, is an object variable. What that means is that an object contains its own variables inside of it. In the case of a sound file, we have this giant array of samples, right, that make up individual tiny little pieces of the sound. And then on these variables, we have methods. Methods are functions of an object that basically give it some abilities. Okay? So the sound file has different methods or different abilities like get peaks, right? Or current time or duration, right? All of these are methods of the sound file object. And of course, we can have multiple sound files, right? Multiple variables. When we use the methods, we use them on actual instances of that object. So sound here is my actual variable, and we use the dot here to connect the object with its method or its attribute. But in this case, the sound file doesn't have any fields, doesn't have any attributes. It only has methods. So once you have a sound file object, these are basically all the things you can do with it. How do you know what methods your object have? Documentation. There's no other way around that. When you're programming with objects, just like when you're programming in P5 in general, like the reference is how you know what are all the different things you can do. The same thing applies to objects. You're going to be constantly looking up, for a particular object, the list of methods that it has or functions, and this is how you know what its capabilities are. So a big part of programming is reading documentation. Otherwise, you're kind of just going in blind. Okay. All right, so we're going to leave it at that for this week. This is how we use existing objects in the language.